On November 5th, 2020, the United Kingdom went into lockdown. They were trying to control a spike in COVID-19 cases. And if you look at the chart of cases, it seemed to work. But despite having the same lockdown measures, infections in Kent, an area outside of London, were still rising. In early December, the overall drop in cases led the country to relax restrictions anyway. And then, this happened. It wasn't until around this time that researchers realized that somewhere in Kent, the virus itself had changed. It was a new variant. It was more contagious, and it was spreading. By the time scientists gave it a name, it had spread to most of southeast England. 2 months later, it was in 30 other countries. 5 months later, it was the most common form of the virus found in the United States. Lately, more and more variants are emerging in various places around the world. So, why are they showing up now? And what does this mean for the pandemic? Viruses are very simple. They're basically just a shell of protein surrounding some genetic material, either DNA or RNA. That genetic material is made up of molecules that can be represented as a series of letters, like this. Each part of this code contains instructions for how to make one specific protein that allows the virus to function. A virus has one goal: to make more of itself. But because it's so simple, it can't do that on its own. So it uses you. Every time a virus infects a person, it uses their cells to make copies of itself, replicating this complex code again and again and again. But eventually, it makes a mistake. Sometimes it deletes or adds a letter, sometimes it flips them around. That mistake is called a mutation, and it slightly changes the instructions for making the virus. That slightly altered virus is a variant. Since viruses are constantly going through this copying process, it's normal for them to change over time. For example, this chart shows some of the mutations the SARS-CoV-2 virus has made since December of 2019. Most of the time, these mutations are harmless, or even make the virus weaker, and they quietly disappear without making any notable difference. But other times, a series of mutations occur that give the virus a slight edge over us, which is what scientists started to notice with SARS-CoV-2 back in September of 2020. Coronaviruses are covered in spike proteins that they use to bind with and infect human cells. The thing is, that binding isn't a perfect fit, so it doesn't always get past the cell's defenses. But the B.1.1.7 variant, which scientists later renamed the alpha variant, has multiple mutations on the spike protein. Mutations that make it easier for the virus to bind with cells, which can help make the virus more transmissible, which led it to become a dominant strain in many places around the world. But if SARS-CoV-2 has been mutating all along, why do the variants today, like this alpha variant, suddenly seem so much worse? It's important to remember that a virus doesn't make active decisions. It's not as if it creates a strategy within your cells. Mutations are random errors. But the longer a virus is around and the more people it infects, the more it will change. And the more those changes accumulate, the more chances the virus has to evolve into something more dangerous. These 4 variants, considered variants of concern by the World Health Organization, all have mutations on the spike protein. Delta, the most recent addition to this list, has been referred to as a double mutant, because while it has many different mutations, it has 2 significant ones we've seen before. This mutation seems to make the virus more transmissible, and a version of this one, found in 2 other variants, makes it easier for the virus to reinfect people who have already had COVID-19. Meaning these 2 mutations may have evolved to dodge our natural immune response. Fortunately, the immune response we get from vaccines is much stronger than our body's natural immune response. So, while we may see variants that make our vaccines somewhat less effective, most experts think it's unlikely one will emerge that completely evades our vaccines. But that doesn't mean it can't happen.
And replicative cycles, it will sample a very large evolutionary space and find a solution to the problem, we've presented it, which is vaccination and widespread immunity.
But even if SARS-CoV-2 doesn't get to that point, as long as the pandemic continues, and as long as the virus continues to spread, it will continue to make copies of itself. So, if we want to stop the variants, we need to stop the virus. The virus has evolved, but it hasn't morphed into something unrecognizable. The vaccines we have still protect against all the variants. The trouble is, we aren't getting those vaccines around the world fast enough, which is only giving the virus more time to change and ravage areas of the world that are still waiting. The rise of variants is a reminder that the pandemic isn't over, even if it feels like it is to some of us.
We need to stop this because we don't want a variant that affects immunity. And so that involves stopping